In this section, we will explore Python keywords. These core elements form the foundation of Python programming, and understanding them is crucial for mastering the language. We will explore 6 essential categories of Python keywords, each serving a unique purpose in our code. Value keywords, which define our fundamental data states, operator keywords that handles logical operations, conditional keywords controlling the program flow, iteration keywords managing loops and repetition, structure keywords building code organization, and context keyword handling resource management. Let's start with the value keywords, the fundamental constants in Python that represent core states in our program. True and false are Boolean values that form the basis of logical operations. None, Python's special constant representing absence of value. These special constants have unique properties in memory, and they behave differently from similar looking values. Let's look at some practical examples. Notice how false equals 0 when compared. True equals 1, showing the numerical basis of Boolean values. We can even perform arithmetic with Boolean values. None is special. It is not equal to 0 or an empty list. This demonstrates none's unique property in Python. Moving on to operator keywords. These are the logical building blocks that help us combine and compare values. We have several key operators and requires both conditions to be true or need just true condition. Not inverts the Boolean values. In checks for membership, is verifies the identity, not just equality. We start by defining some Boolean variables. The AND operator shows how conditions combine or demonstrate alternative logic. Not inverts our Boolean values, and in operator checks list membership, and is shows true object identity. Next is conditional keywords. They are essential for controlling the program flow and making decisions in our code. If for primary condition checking, else for alternative paths, elif for multiple condition handling. Together they create the sophisticated decision trees. Let's break down a typical conditional structure. We start with a simple variable. The if statement checks for positive values, elif handles the negative numbers, and else catches our zero case. This creates a complete decision structure. Next, the iteration keywords help us repeat actions and process sequences efficiently. We will explore for loops for sequence iteration, while for condition-based loops, break to exit the loops early, continue to skip the iterations, pass a null operation. Let's examine two common patterns. First, a for loop with continue. We iterate through numbers, skip processing when we hit 2 and print the remaining values. Then a while loop with break. We count up from 0, break at a specific condition. This gives us the precise control. The structure keyword helps us to organize and reuse code effectively. Key structural elements include def for function definitions, class for object-oriented programming, return for function output, lambda for quick anonymous functions. Let's explore these concepts. We define a simple greeting function, create a dog class with methods, and see how the constructor works, and demonstrate the lambda functions. Each structure serves a specific purpose, you can see. Finally, let's examine the context keywords, which helps to manage the resources efficiently. With for resource management, as for naming and binding, simplify cleanup operations, they ensure proper resource handling. As we have seen, Python keywords form a rich vocabulary that enables comprehensive program control, advanced code structuring, efficient resource management, and flexible programming techniques. These are the basic building blocks of Python programming.